All right, welcome back, everybody. We're continuing our chapter on the probability. We're gonna do 5.2, 5.3 today, and as much as the 5.4 as I can get done. So 5.2 is on the addition rule and components. So I'm gonna start this off with an example for you guys. I'm going to make an assumption here that everybody has played the game Monopoly. If you haven't, you don't need to play to get what's gonna happen here, but this is an example for Monopoly. A lot of families, let free parking have a prize on it. They put their taxes, they put their, everything the game collects, they store it into there, and if you land on free parking, you get it. So let's say, you're on electric company. Which is 8 spaces away from the free park. You have already rolled doubles twice. So a third doubles would send you to jail. Either option sounds great to you because you're losing. And when you're losing, you do not want to be going around the board, landing on property to pay other people rent. You want them landing on your shit and you sit in jail just like nice and comfy. So you want to roll an 8 or roll doubles. All right, so let's look at the ways we can roll an 8. You could roll a 2 and a 6. You could roll a 3 and a 5. You could roll 2 4s. You could roll a 5 and a 3, which is different than the 3 and 5. You'll notice that, yeah, like we did the dice thing last week, so that should be a little bit familiar to you. You'd also roll a 6 or a 2 in the 2. So like, let's say the first die is a red die and the second die is a white die, you can clearly see that there are different outcomes. If we want to roll doubles, you need these to match. So the probability of rolling an 8. How many outcomes do we have here? We've got 1, 2, 3, 4, 5 outcomes. So that would be 5 over the total, which was 36. We had 36 from last week when the 36 ways to roll 2 dice. We saw that last week. We wanna look at the probability of rolling doubles. We have 6 outcomes here. So this would be 6/36. So how many ways can I do both? Let's count them up as we go through them. I'll do all the pairs first, that's 6 different pairs or doubles. Then this would make a 7th option. The 3 and the 5 would make an 8th option. The 4 and the 4, I already counted that, so that's not really another option, that's not a new option. So I'll put my finger over the 4 and 4 for a second. The 5 and 3 would make a 9th option, and the 6 and 2 would be a 10th option. So there's 10 outcomes of those over 36. What happens if I would have just added together the 2 probabilities separately that I had? I'm starting to curve, is that right? I would have had 5/36 plus 6/36. Which is 5 plus 6/36. 11/36. Which is close, but not quite. What is it off by? It's off by a single outcome, right? Why? What is it, what do you mean?
There's 2 the same ones.
When we did both of them, we counted the 4s twice, right? The pair of 4s was counted twice. So if I said probability that the roll equals an 8 and the roll equals doubles. There's only one way for that to happen. It's the 4/4 option. So it looks like we could have gotten the probability that the roll equals 8 or roll equals doubles. If we added the 8, probability of the 8 with the probability of the double. And subtracted the probability of the 8 and double. And I stopped writing roll because I got tired of writing roll, but I think you get the picture here. This was 10/36 equals 5/36 plus 6/36. Minus 1/36. 5 plus 6 minus 1. Tough. Does anybody's family play Monopoly? Hope not very often, it is not a very fun game. It's not good for families. It's like someone loses early, unless you're like really leaning on rolls. Someone loses early and they're like, They're probably like good, I'm fucking glad I can lose some else.
I get literally paid to play.
Get the fuck out of here.
Yeah, I work in a convalescent home and all I do Sundays is play board games with them and they love it.
You get paid to play board games, that's fucking, what else do you get paid, do you have to like, you have to clean their beds or anything like that, or is it just fun shit?
No, I don't want this.
I do. I'm like that.
I
She's like,
work,
how do I get your job, I don't know what to ask, I'm gonna play board
Your
games.
dog, the shitty mistake, literally.
I work in sensory and so we do a lot of like, we get their minds moving. So a lot of games, I had to get them to listen to music, different eras, things like that, just get them talking,
Like an activities coordinator kind of thing,
yeah, so.
that's fucking cool. I'm a little jelly.
Sometimes I just have to reteach them how to play catch with the ball.
That's it's easy to forget how to do some basic skills when you get old. All ready for more? That's fucking cool. Oh, I don't know, Monopoly. I guess if you're paid to do it, you keep playing, no matter, you know. You lose with them, you go over to do another table and you're not sitting around waiting. Problem with Monopoly is people lose and it's like the last person standing wins. Games where that happens, people are just sitting on sidelines for a long time, if you, especially when you have. Games that are fast, it's not a problem, like werewolves and shit like that. That people die pretty quickly and the game's over pretty quickly. But like Monopoly can take fucking forever. Alright, so, we have a little pattern here. We can generalize this. So it's called the general addition rule for probability. For two events E and F. The probability E or the probability of E or F. Is the probability of E plus the probability of F. Minus the probability that something is both. And like we saw in the last one, this thing is where E and F overlap. Or have something in common. You know, there's one thing that I, like when I was in high school, I went and hung out. Like as an activity to hang out with at a convalescent home like once a week. Well, I wasn't gonna play games, but I was just listening to them, listening to the stories. Old people have fucking great stories, cause they grew up in a time that. I guarantee you cannot fucking imagine. Most of the people in the convalescent home now are probably. Born right during the Second World War and lived like in the time right after that. There's no fucking internet. There was barely television. Flying was new. Like airplanes weren't like a commercial thing yet. When I was your guys' age, it was like fucking World War I people. And they lived through World War II, so you hear all sorts of crazy shit. Stuff couldn't even imagine. It's great, they kind of have good stories. Alright, so on to this, what if we had something different, what if we had, what about rolling and a 3 or doubles? Well, the ways to get a 3. We already did the doubles. So ways to roll a 3. We can have 1 and 2 or 2 and 1. So there's 2 outcomes. So the probability of a 3 is 2/36. And we have the probability of doubles. Is 6/36. If we plug our stuff into this up here. Probability of 3 or double. We get 2/36. Plus 6/36. Minus, what's the probability of 3 and double? Is there any overlap between those? The closest we can get is 1 or 2. This gives us a 2, this gives us a 4. 3 is between, there's no way to get a 3 and doubles at the same time. So if we subtract that probability, it's minus 0/36. So 8/36. Which is just probability of 3 plus probability of doubles. So rolling a 3. And rolling doubles. It's called disjoint events. They have nothing in common. Another word for disjoint events, not word, they also say mutually exclusive. The outcomes in one exclude the outcomes in the other, and it's 2 ways. And when that happens, the probability of E and F is 0. Which actually makes the above equation easier. For disjoint events. We have probability of E or F. Equals probability of E plus probability of F. And when you're doing the interactive assignment, it might do them in the other order, it might show you this one first. But I think showing the simpler equation is the fuck way to go. Because people have that in their head all the time. See it in algebra classes too. When you learn the simplest one and then you don't know how to do the harder one. Harder one still works. It just makes this 0. So the top equation works all the time. This equation only works when they're disjoint events. You're better off memorizing just the top one alone. You guys ready for sport? Are we having fun yet? You're lying to me, Amar. Fucking you are. I made it a word talking about board games. Like fucking make it about fucking roulette or poker, then we're talking. We'll get there. Alright, next topic in this section is complements. And it's not like giving someone, paying someone a compliment or giving a compliment, like you look nice today. That has an I right here. This definitely has an E there and there. It's spelled differently than giving someone a compliment. So the complement. Of event E. And it's denoted as. E with the C above it. The C looks like an exponent. Contains every outcome. Not in E. So like if E was roll doubles. Then E complement is the roll. Or don't roll doubles. Does that make sense? It's like everything else. Well, we already said this one, the probability here was 6/36. If you look at the grid we made the other day. There are 30 ways to not roll doubles. You can go count, I'm not gonna relist the table, but trust me, it's 30. So if I add the probability of E plus the probability of the complement of E. I have 6/36 plus 30/36. Which is 36/36. Which equals 1. So this is a pretty important equation from this section. The other important equation was. Probability of E or F. Equals probability of E plus probability of F. Minus the probability of both. And those are the big ones from this section, that way you have them right next to each other. In your notes, you could make it easier to find them, yeah. So. If the probability. Two mutually exclusive events. Add to 1. They are complements. Types of questions you'll see in this section. So like question types. Let's say you have a bag. They have stupid ones. You have a bag with 5 red balls. 6 green balls. And 9 purple balls. If you draw a ball at random. What is the probability? It's. Green or purple? Well, how many total balls do we have? 20. 5 plus 6 plus 9. So what is the probability of a green ball? There were 6 green balls out of 20. And they might have you turn this to a decimal. This is 0.3. What is the probability? I should have wrote the green ball and the green pen. Fail. What's the probability of a purple ball? There was 9 purple balls out of a total of 20. If you throw that into a calculator, you're gonna get 0.45. Usually they ask it as a decimal, but they might ask you to put it as a fraction. So just be prepared for either. But you generally start with the fraction and then you get the decimal from it, so you would have both. So the probability of green or purple. Should be the probability of green plus the probability of purple. Minus the probability of both. Green and purple. I'll say G and P. Cause I didn't give myself a lot of room. This was 6/20. Plus 9/20. Can a ball be both green and purple at the same time? No. So there are no balls in the both green and purple category. So this is 15/20. And this is 0.75. And you would get that if you added the 0.3 and the 0.45. So depending on if they want the fraction or the decimal, both options work then. I'm off the screen and no one said anything. Let's see. 5, 10, 12, 13, I make 13 pieces of here. And then 5 and 13 labels, we're gonna use us in an example in a second. Alright, you guys ready for the next scenario? In class right now. We have. I'm assuming everybody identifies as binary. If you don't. Work with me here, we need two outcomes, right? We have 8 males or 8 men and 5 women. Or if I misidentified your gender, I'm sorry, but I'm not saying who's the women and who's the men. So maybe you'll be okay with. If we pick 4 at random. Go back to clock. If 4 are selected randomly. What is the probability? That at least one is a woman? So let's look at our options here. Options, if we're picking 4 people. How many women are picked? I could have 0, I could have 1. I could have 2, I could have 3, or I could have 4. What does at least 1 is a woman? What numbers of those count as at least 1? Is 4 at least 1? Is 3 at least 1? Is 2 at least 1? Is 1 at least 1? Yeah. Is 0? No. This is a bitch to calculate. We haven't even done the steps on how to calculate 0 yet. Which we're leading to. But that's what we need. We need this. But if I look at it in terms of complements. Another way of saying 0 women is all men. All men were selected. So these are complements, and these are the only possible outcomes we have. So all men is like the complement of at least 1 woman. So we're gonna use that probability equation that had complements. And I'll rewrite it here before I put in what's in there. So if I want so if I put in all men, this is probability of all men. Plus the probability, the complement of all men. Equals 1. Or probability of all men. Plus the probability of at least one woman. Equals 1. What we want is this. So if we subtract the probability of all men from both sides. We can find our answer actually a lot quicker. Probability of at least one woman. Equals 1 minus the probability of all men. Now, what does the all men mean? This is 1 minus the probability that the first person is a male. And the second person is a male. I'm using M for male. And the third person is a male. And the fourth person is a male. We don't know how to do this yet, but we will shortly. Guys ready for it? We're gonna start 5.3, which is on independent events. And hopefully get to 5.4, which is dependent events. We're gonna come back to that problem a little bit. So what we were doing in the last section was a single event, rolling the dice together and doing the outcome. So what was the outcome of sum? So. If we have two events. Going on. And the outcome of one. Doesn't affect. The probability of the outcome of the other. we say these events are independent. So things that fall in this category is like. Rolling dice. Not adding them up, but just rolling dice. Sure, they may bang around in the air, but when they land. The probability for a die. Isn't changing. These are independent. Probability of one isn't affecting the other. No matter how many you throw at once. Sure, the outcome might be altered because they bang, but the probability isn't altered. If we draw cards and put them. Draw cards and put them back. Draw cards. One at a time. And put them back. This also counts. And you will see that they will talk about this in the homework. As drawing cards with replacement. When they say with replacement, they're saying. You draw the card out, you put it back in. After the midterm, we'll do an activity with it, when we start hypothesis testing. I'll have you draw a card one at a time, we'll put it back in and we'll make an hypothesis and. Do some good stuff with it. If you draw cards without replacement. Like if you're dealing in a card game. This is considered dependent events. And we also call it conditional probability. And that's in 5.4. And we'll talk about why. It's actually a fairly simple concept. You may not like the math when it's done, because it can get tedious, to say the least, but it's not too bad. Let's say we wanted, what is the probability of rolling a 12? With two dice. This is the probability that the first die equals a 6. And the second die equals a 6. There's no other way to get a 12 with two dice. So the probability of a 12 is 1 out of 36. What's the probability that the first die equals a 6? How many sides does the dice have? 6. So there's 6 ways it can come face up. That's my total on bottom. How many of those options on the die are a 6? Just 1. What about the probability that the second die is a 6? Is it any different? Guess what? 1/6 times 1/6 equals 1/36. So like, let's say if I called this probability of E and F. This would be probability of E. This would be probability of F. For independent events. The probability of E and F. Equals the probability of E times the probability of F. And let's take a 10-minute break. Before we lead into some examples. Alright, so let's continue on with this bad boy with an example. I don't know how many of you guys have played Yahtzee? Has anyone played Yahtzee? No, okay, you have. I know you had to have had.
What was it?
Yahtzee?
Oh my god, it's terrible though.
It's not terrible, it's just not the most exciting game. So is most board games. So, Yahtzee. My wife makes me play this with her cousin whenever they come over. Yahtzee is, let me spell it right. It's a game where you roll 5 dice. And shoot for specific outcomes. You get 3 rolls. And you can keep dice from any roll as you're going. I.e. not re-roll them. As you go. That's how Yahtzee's played, since most of you have not played Yahtzee. An actual Yahtzee is a move or is an outcome in the game. A Yahtzee in the game is considered 5 of a kind. So like your goal to get a Yahtzee, and let's see, find the probability of getting a Yahtzee in 1 roll. The game is substantially more fun if you scream Yahtzee when you get Yahtzee. Scare the shit out of people that aren't paying attention. So this is like doing the probability of all ones. Or probability of all twos. Or all threes. Or all fours. Or all fives. Or all sixes. And I'm gonna stop writing the word all for the next thing, but we found what the probability of, what the or did. What did the or turn into? Within the last hour. Like rolling a eight or rolling doubles, what did or turn into? It's a plus. So the probability of ones plus the probability of twos. Plus the probability of threes. Plus the probability of fours. Plus the probability of fives. Plus the probability of sixes.
Oh,
Have you played Yahtzee?
yes.
Okay.
Been a while, but yes, I have.
You're like one of three or maybe, well, if we count me, four. Maybe more, but the rest were like, I'm not raising my hand, or you're gonna not. And we're not gonna do the probability each one, because they're all the same. So let's just do the probability of rolling fives. Let's look at probability of fives. Probability of all fives. No, let's go with all fours, because we have 5 dice and I don't wanna use the same number there. This is the probability that the first equals a 4. And the second equals a 4. And the third equals 4. And fourth equals 4. And the fifth equals 4. Now, all of these dice rolls are independent of each other. So we just saw what and does. And turns into multiplication. This is the probability the first equals 4. Times the probability that the second equals 4. Times the probability that the third equals 4. Times the probability that the fourth equals 4. Times the probability that the fifth equals 4. Well. Each of these is 1/6, right? They're all 6-sided dice and only one outcome is a 4. So these are all 1/6. And multiplying these together, we get 1/6 to the fifth. Power, or 1/7,776. So let's circle one, that was just one Yahtzee. But all the Yahtzees have the same outcome. So if I do this, this is probably the ones is 1/6 And I'm doing that because it takes less writing than 7,776. Probability of all twos is 1/6. The probability of all threes is 1/6. All fours was 1/6. All fives was 1/6. And all sixes is 1/6. And if we add those up all on top, we got 6/6, which ends up being 1/6, which is 1/1296. You don't have a very good chance of getting Yahtzees in one throw of the dice. You actually don't have a very good chance of getting it in 3 rolls where you get to pick up the ones you want. It doesn't happen that often. It happens more often than the fucking leaning jowler. There's a slightly quicker way to get to this answer. But this answer is this approach is valid, the answer is the same. So I want you all to stop and think about it. If we roll 5 dice. And we want them all to match. Does it matter how the first die lands? Like, let's say my first die is a 3. Does that affect things? Or it's a 1, or it's a 2. It doesn't really matter what the first die is. No. All that matters is that the rest match it. So we did a lot of calculations here to get to the 1/1296. This actually simplifies to probability that the second equals the first. And the third equals the first. And the fourth die equals the first die. And the fifth die equals the first die. And the and turns into multiplication. And it doesn't really matter what the first die landed on, my second die only has one way to match it. Out of the 6 outcomes. So there's one match. Over 6 outcomes. Each of these is 1/6. And when we multiply that together, we get 1/6 to the 4th power. Or 1/1296. You guys ready for a gambling example? Do we need this up longer? Alright, we're gonna talk about Texas Hold'em. Texas Hold'em is a poker game. You get two cards that are face down. And these are your cards alone. They go by the name the pocket cards. Or hole cards. I'm not flipping you off, I realize I'm just using my middle finger, why I did that. From that. Then there's 5 community cards that come up, they deal them out. There's a round of betting. And then they put up three up cards. Everyone can see them. And everyone shares them, and this is called the flop. And there's another round of betting or folding. You get a 4th card up called the turn. Another round of betting. A 5th and final card that's up. And a final round of betting. And this final card is called the river. Everyone shares these cards in their hand. Everyone uses these cards to make a poker hand. With their personal hole cards or pocket cards. Now, if you've never played poker, it takes too long to go over the ranking system. But the important part is no one knows what you've got in your pocket cards. The best hand to have in the pocket is just play hold up. What's the best hand to have in your pocket? That is not, you've got 2 cards,
This one's pocket ace.
pocket aces. Pocket aces, also called pocket rockets. Because they have an A in the corner and the A looks like a rocket tip. After that, you could argue stuff for a royal flush like ace king suited. But then we'll say any pocket pair after that is usually pretty good. So let's look at pocket aces. What's the probability of pocket aces? You know? Anyone know? So it's the probability that your first card equals an ace. And your second card equals an ace. And this turns into multiplication. As and always does. Fresh deck. How many aces are in it? There's 4 aces out of how many cards? 52. Second card. How many aces? There's only 3 left now, right? You already have one of them. How many cards are left in the deck? 51. Notice that the probability has changed. This is called conditional probability. And the way we would write it is the probability that the second card is an ace. Given that the first card was an ace. And we have a shorthand way of writing that. They don't say given that, they will do a vertical line. And a generic way of writing this is probability of F given E. And that's how we say it, probability of F given E. So it's like, what is the probability? Probability that F happens. Assuming E has already happened. And you notice the probability changed here. Well, to finish this out, 4/52 simplifies into 1/13. And 3/51 simplifies into 1/17. And if you multiply 13 and 17 together, you get 1/221. And if we put that as a decimal, 0.0045. And for the folks that were doing the whole. Math 321, we were talking about scientific notation. My calculator gave me scientific notation here. So I did times 10 and shows the -0.03 there. And I moved the decimal left 3 times. If I turn this into a percentage. This is 0.45%. That's a pretty unusual event. So pocket aces is unusual. Remember, we define unusual as below 5%. We talked about that a couple days ago. So rewriting this pocket pair notation thing here. We would say, I'm gonna say first equals ace. I'm gonna write it as A1. Does that sound fine? And then we'll do second ace is A2. So the probability of pocket aces. Is the probability of A1. Times the probability of A2. Given that A1 has already happened. And if I write what pocket aces is, this is probability giving an ace on your first card and an ace on your second card. So this is another, like if I relabel this with E and F. Probability of E and F. Equals the probability of E. Times the probability of F given E. These are for dependent events. Which is 5.4, we're in 5.4 now. We already had a probability of E and F though with the independent group. When we had independent events, we had the probability of E and F. Equal the probability of E times the probability of F. For independent events. But those are the two important formulas to remember from 5.3 and 5.4. Again, probability that F given E. Is the probability that F occurs. Assuming that E has already occurred. Or happened. Let's go back to any pocket pair real quick. Just to reinforce on that idea for a second. So the long way of doing this is the probability of aces. Or kings or queens. Or jacks. Or tens. Or nines. And going all the way down to or twos. And all of these ors would turn into a plus. And we can do it like we did the Yahtzee. But. If you're going for just a pair and you don't care what pair it is. Just like the Yahtzee, it doesn't matter what the first card is. The shortcut way. Is just a single probability. The probability of any pocket pair. Is the probability that the second card matches the first. And for that to happen. It doesn't matter what card we hold. There are only three others like it in the deck. And there's only 51 cards remaining. This simplifies to 1/17, which is 0.0588 or 5.88%. In stats, we don't call that unusual. But it sure fucking feels like it when you're playing poker. My wife's family, they even eventually had a poker table in the house. Before one of the oldest people passed away. We would get together and play poker maybe twice a month, it was like a $10 buy-in, you got a certain number of chips, and it was play till there's 1 minute and they got the top. And my wife's cousin Rhonda, she wouldn't fucking fold ever, ever. It didn't matter if she had 2-7 offsuit, which is. In general, the worst hand to get. It's a winning hand, very rarely. You like need all twos to show up on the board or all sevens, so it is a winning hand, but not very often. Pocket aces win more often than pocket or 2 and 7. But. If she keeps calling and everybody else keeps calling. Aces don't win very often if there's too many people on the fucking board playing till the end, right? For those of you that have played. You've had it happen, you've had your aces crushed, you're like, motherfucker. And no matter how much you bet, you can't fucking, you wanna bet enough to get them to keep paying, but you don't want everybody to keep paying. Cause then someone will fucking suck out a winning hand on you. They'll fucking get lucky and draw a winning hand when the odds were completely against them. That's, pocket aces don't win enough again, depending on how many people are in it, they don't win often enough. There's a way of calculating the probability F given E, but it requires having some of the information already. If we take that top equation. And solve for probability of F given E. We get the probability E and F. Over the probability of E. Let's go back to that fucking boy girl one. Where is it? I had that here. We have what we need here. You guys ready? So back to the scenario, we had. 8 men, 5 women. And we picked 4 at random. And we were looking for the probability that at least one was a woman. And we looked at the complement approach, which is much better. 1 minus the probability that they were all men. So I'm gonna do that subscript like I did with aces, I'm gonna put a 1 underneath them or 2 underneath them. To say which order I drew them. So like, let's look at the probability of all men. And we'll have this equation in the results here in a second. This is the probability that the first is a man. And the second is a man, given that the first was a man. And the third was a man, given M2 and M1 happened. And the probability that the fourth was a man, giving all three men before. And our ands turn into multiply. So when we start off, there were 8 men, 5 women, so there's 8 different guys I could pick from. How many of them, how many total? How many total people were there?
13.
13. You're just adding the 8 and the 5, this isn't overly complicated, don't overthink it. If I've already picked one man, how many men are left?
7.
7. And how many people are left? 12. And we want the third person to be a man, assuming the first 2 were men. How many men are left?
6.
6. Out of how many people were left to pick from? What's the pattern going on here?
It's going down by 1 each time.
You've gone back down by 1 each time. I have no idea what this equals. I'll do the fraction in a second, but the decimal is 0.979. Or 9.79%. Is that the answer I wanted to find though? No. I wanted the probability of at least one woman. So the probability of at least one woman. Is 1 minus the probability of all men. 1 minus 0.0979, or 1 minus whatever I got here. Zero point 902. Or 90.2%. What's wrong, Amar?
Okay. Let's try to do that from this one.
Next, let's go back to the bag with the balls. You will see questions like this on the homework. You'll also see questions very much like the bag one or the ball one. So we're back to, we had 5 red balls. 6 green. And 9 purple. And they'll do shit like this, they'll say probability, so you pick 2 balls. Probability that both are green. This is the probability that the first is green. And the second is green, we'll just do G. Given that the first was green. So we get probability. Using that subscript I had earlier. Probability of G1 times probability of G2 given G1. We said there was 20 balls. So the first ball being green, there was 6 out of 20. And just like we saw in the last one, we dropped this down by 1 and dropped this down by 1. This is 30 over 380 or 3 over 38. .0789. They're usually going to want you to put decimals into the answer, not percentages. Every once in a while, they will ask you about percentage. So you gotta pay attention, oftentimes they'll have the percent symbol listed after the box. That's not it though. This problem always has 3 options. That's like part A. Part B is gonna be probability both in purple. And this is gonna have the same setup. Probability that the first is purple. Times the probability that the second is purple. Given that the first is purple. And I'm writing PUR for purple rather than P because there's already P's there. And I don't wanna make it confusing. There were 9 purples out of 20. And second set, there was 8 out of 19. So 72 out of 380. And I don't know what that reads to. .189. I was rounding, that would be to a 5. I think there's one like this on the midterm too. And A and B, most of you will like, by that time, you'll have enough practice so that you'll get it. Part C is the one that's gonna fuck you. It's gonna fuck up enough of you that you're gonna get it wrong. Part C is gonna be the probability of 1 green and 1 purple. They have other problems in it like code for, or like you have a 18 pack of soda, but like. They mistakenly put a few diets in and you're like, what's the problem with getting a diet? What's the problem with getting not a diet? What's the problem with getting one each? You'll see a bunch of these like there and there. This is the probability that the first is green. And the second is green. Given, or I'm sorry, second is purple. Given that the first is green. Or. The probability that the first is purple. And second. Is green, given that the first is purple. And a nicer subscript. Probability of G1. Times the probability of purple 2 given G1. The or turns into a plus sign. Plus. The probability that the first is purple. Times the probability that the second is green, given that the first is purple. Let's just look at what happens when we do it. If the first ball is green, there is 6 green out of 20. And you might want to do the next number lower, but the number of purples hasn't changed. There's still 9 purples in the bag. What has changed is the total. 15. Then we have plus. Now start back over, all the bags are, marbles are, or the balls are in the bag. The first one is purple, is 9 out of 20. The second one is green, there's 6 green balls out of 19 balls. You put this together, you have 6 times 9 plus 9 times 6 over 29 is 19. You can actually simplify that top to 9 times 6 times 2 or 20 times 19. And I'm getting 108 on top. 380 on bottom. .2842. There's a few more things I want to do in 5.4, but we'll get them done on Thursday. I don't know what fucking day it is, Thursday, along with 5.5 and 6.1, and we'll be caught up. And I did adjust the due date for 5.2 to make it due with this shit's homework activity. Have a good day, evening, I'll see you guys on Thursday, get the fuck out. What Alfredo?